Okay, okay, listen. The unit 3, the transformer. The transformer is the static device or stationary device, we can say like that. It's have the two different winding. That is the primary winding, which is connected to the supply, input supply. So that is called the primary winding. Then the secondary winding, it's connected, always it's connected to the load. Okay, based on your requirement, we can select either step up or step down transformer. If it is, we can consider as the step up transformer while we are compared with the primary winding. Number of turns which is present in the primary winding is, yeah, if you are considered as the step up transformer, you can see that diagram. You see, that is the input supply. While you are connecting the supply in the primary supply in the winding, that is called the primary winding. That is the, so primary winding and the secondary winding, Vs is the secondary winding. So the voltage in the primary winding is the low and voltage in the secondary winding is high. So based on the number of turns, the N is indication of number of turns in the primary winding, number of turns in the secondary winding, whereas based on the number of turns in the primary and secondary winding, we can say that either step up or step down transformer. In the case of this kind of transformer, whereas the NP, that is the primary number of turns present in the primary winding is low compared with the secondary winding. If you are considered like that, so that is the step up transformer, right? So the primary winding is, number of turns present in the primary winding is low, number of turns present in the secondary winding is high. So definitely voltage between the primary winding and secondary winding, so the voltage is high. It means that the voltage has been transformed in the high level or step up in the voltage level. So based on the turn ratio, that is the turn ratio. Suppose if you are considered as there is a step up transformer. Similarly, if the number of turns present in the primary winding is high compared with the secondary winding, that means the secondary winding number of turns present in the secondary winding is low, right? So that is the N secondary, then N primary. So number of turns present in the primary winding, NP is greater than the Ns. It means based on the number of turns present in the winding, the voltage has been raised up as well as fall down, right? We can select this as the case of the step up transformer. This is the step down transformer, right? So this all the basics of transformer. So the transform the voltage level from the one winding to another winding according to the mutual inductance principle based on the number of turns present in the primary winding and the secondary winding. We may call it as either step up or step down transformer, right? So another one transformer that we are using in the machines, that is the isolation transformer. The isolation transformer in the sense the primary winding and secondary winding, it should be both are equal. You can consider like that. That is the primary winding number of turns, then secondary winding number of turns, that is the NP and NS. So the NP, it should be equal to NS. That is the case of isolation transformer. Rarely we are using. Okay. So that is the introduction about the transformer. So in this particular unit, as in the electrical machine design point of view, we should select the transformer and we can, based on our requirement, we should select the transformer. Then we can use it for the either step up or step down, and the number of turns present in the primary winding, number of turns in the secondary winding, then the window, that is the, this is the window. So the window, width of the window, then this is the height of the window, HW, right? So width of the window and the height of the window, that is the main dimension of the transformer. That also we are going to find it out. Okay, while we are designing in the machines, that is the rotating machines, we are find it as the main dimension, diameter and length. Like if you are consider the rotating machines like this, so here it is the diameter and this is the length that we are obtained in the previous unit. That is the DC machine design. So the diameter and length was the main dimension. Similarly, in the transformer, the transformer means you all know that is the basic, that is it can be transfer the voltage level from one ratio, one angle, one level to another level. Either it may rise up or it may fall down. That means step up or step down. But as per the design point of view, you should find the main dimension, that is the width of the window and the height of the window and overall height of the transformer. And if you are suppose you can add somewhat the cooling circuit in the transformer. So the cooling tank design, that also there. That all we are going to discuss in the particular unit. That is the overview about the transformer. That is the introduction about the transformer. Then hereafter, step by step, we can go for deriving of output equation and rating of transformer, right? Either single phase as well as three phase. That all we are going to design, and finally we can design the cooling tank of the particular transformer. How many cooling tubes you should fix in the top of the transformer to cool the transformer inner parts, like while you are passing or step upping or step downing the voltage, that time it may the heat has been, temperature has been raised up. So by adding the cooling tank, so how many number of cooling tubes are required to cool the transformer, that also you have to design. That is the last topic of this particular unit. That is the overview about the transformer.